Welcome. In this video, I'm going to walk you through NUKE, a cross-platform build automation system which uses C# as its DSL, right? So that basically means it's not limited to the C# world, and you're going to see how that can be done throughout the video. However, most of the API primarily extends towards the .NET world, so working with the .NET ecosystem. So before diving into NUKE, let's take a look at this sample application, because it will be important to understand where NUKE stands next to it. Here we have a test API, a functional test project, and a unit test project to test the test API. Okay. So the test API itself is really simple. We have our top level statements where we run our application. The startup contains a list of cars where you can imagine that this is a database. Then we basically configure our endpoints where for /cars, we're going to list our cars, and /cars/name, we grab a car with a specific name. And then we just have a record of cars. Okay, so nothing too complicated here. In our functional tests and our unit tests, if we take a look at the unit tests, this is not a real unit test. Do not test C# functionality. This is just an example of a unit test. Primarily, you want to test your business logic, right? But anyway, that fact aside, just a unit test that we want to see being performed by NUKE. And then a functional test where we need an instance of our application to be running in order to verify this. So where I had the 3 best cars in the world in a list here, what the tests are doing, they're basically going to query the application at /cars and /cars/Volvo to make sure that we indeed get the Volvo and we indeed get the 3 best cars in the world, right? I wasn't sure about Ford here, but you know, I had to make something up on the spot. I was in a hurry. But Volvo and Lada, irreplaceable. Come on, serious. Those are the 3 projects. Now, usually if you are trying to implement build automation, what you would do is you would go to GitHub Actions, you would search for relevant actions to get your tools, execute those tools, and you would write up a big YAML file. If you would want to port, for example, to Azure pipelines, what would happen is you would mostly have to rewrite that YAML file, because GitHub Actions are not compatible with Azure Pipelines version. I think it's called Tasks. They're not compatible, so you're gonna have to rewrite that giant YAML file anyway, right? Now, what you can think of NUKE is like basically condensing that YAML file to the size only needed to kick off NUKE, because NUKE is then gonna take care of everything, right? So that makes it very, very easy to basically even jump around between build service providers. Okay, but yeah, primary thing that I want you to take away from this is that you have a YAML file, you delete it, and then you bring in NUKE. Okay, so NUKE replaces YAML, but it also brings a lot more things that having YAML or that other build systems don't provide. Anyway, let's go ahead and jump to the documentation here, because I don't remember this command. We're gonna go to the setup section here, and we're gonna use .NET tool install NUKE. Let's open up the terminal, and we're going to install the tool. For you, it will install. For me, it says that it's already installed. Now, what this gives you is it gives you a new global tool to use. So kind of how when you would install EF Core, what you could do then is .NET EF and then add migrations and whatnot. If you're familiar with the Node Package Manager, if you install a global tool like Vue CLI or Angular CLI or Ionic CLI, or if you install ngrok, you then have to put an environment path variable to point at this executable, and then you can use it from your command line. This is exactly what you get now, although you get NUKE. Okay, so let's go ahead and run it. It couldn't find the .NUKE file. That's how it finds out your solution, but we'll actually go over that in a bit. Let's go ahead and just say yes. How should the build project be named? _build and the location /build. As the creator explains it, it's because he prefers these build directories and projects at the top, so they kind of like stand out or whatnot. I don't know. I think it's pretty comfortable. NUKE version 5.0.2, latest release. Again, this tool works very, very well offline. It comes with its documentation that you can inspect, and we'll take a look at how that happens. And if it basically caches the versions. So for example, if a new version gets released, you can't get it, but you can use one of the previous versions and any of the previous versions that you've used before, right? Next few parts is like which solution should be the default one. Yeah, this solution, you know, obviously. Do you need to get help getting started with the basic build? Yes, get me started. We will look through what it gives us. .NET CLI, you saw you had a what's it called, the choice between mono and whatnot. Source files are located, so this is only important if you sort your files into like src, docs, tests, output artifacts, build or dist or whatever. So for now it doesn't really matter for us. I'm gonna select neither for my source, neither for my output, and same as the source for my test packages, right? They all live just there. And get versioning, I'm not gonna be using any versioning here. So what has that done to our project now, right? You will see that our build project has appeared. So if we take a look at the file system here, the build project itself lives inside the build directory, okay? We do not, if you take a look at the solution files, some of the files that are here, so boot and config, these are just linked files to these ones. So let's go to the file system and we will inspect those through here. So .NUKE SLN, as the error message implied here in the beginning where it couldn't find the .NUKE file, now it can. This basically points to your main solution, okay? And that's all it is. As for the other three files, these are basically entry points to your script, or rather to the NUKE console application that is going to run. This like basically sets it all up, make sure you have all the correct tools installed and stuff like that. So as you are running NUKE, you would either be doing it through the command line on your local environment or through one of the plugins that it provides for you. So if you're using Visual Studio, VS Code, Writer, or ReSharper, each of one of those has the corresponding plugin to work with, okay, to make the experience slightly better. It's already pretty good though, so you don't need the plugin. I mean, I'm not using the plugin because it's a newer version of Writer. I don't have it available yet. Let's take a look at build. Build is a console application. First thing that you need to understand about NUKE, it's just a console application, okay? What can you do with a console application? The thing that you can do with any other application, you can debug, you get code completion, you get refactoring, all sorts. Like, as I was saying, for example, documentation inspection, for example, Control-Q keybind for me to show the documentation. I mean, you can read through it. Code inspection, you want to see what stuff does. I don't think you would be able to do this in Visual Studio. Let's go ahead, close this. Let's take debug. Yeah, let's just put a breakpoint here, and wrong button, and let's run debug on this project. And there you go, right? So if you run into any problems, you can just debug your way through. All right, let's blast through that and let's take a look at some of the parts of build. When you define your YAML file, it's generally kind of like the steps that you want to perform. This is what targets are. So clean, restore, compile. I mean, this should be pretty self-explanatory. If you've ever built any CI/CD pipelines before, you separate it into logical steps where you feel like you need to perform specific things, right? So if you have 10 projects, you want to run clean first, restore, right? So it first cleans all of them, restores them all, maybe cleans the output folder as well, where you're going to place your artifacts. And then you maybe build one, you build the second, maybe you want to separate the builds a little bit. Then you want to run the tests, you want to publish the NuGet package, you want to publish your application, you want to publish it to the NuGet feed. All of that can happen here, okay? And targets are primarily the things that are responsible for executing that logic and being those steps. It will be a little bit more apparent in a second, but take note that execute, build, and we say that the compile is basically our entry point. Here we say that the compile target depends on restore. So before compile can run, it depends on restore. So restore has to run first for compile to run. You also have clean, But here you have before, which we'll go over in a second what it does exactly. But let's also take a look at how can we run or execute this build, right? If you have a plugin, you can run it from a more convenient window depending on your IDE. I don't have one, so let's go ahead to the command line, and here just type in NUKE. This is going to build your build application, and one thing that you will see in your solution is it's marked as not build, which basically means that in the properties it is excluded from the build when you build your solution, okay? And that's primarily because when you run your application, you don't, if you're trying to build the whole solution, you don't build your NUKE build project, okay? Because it's running, it's executing, you don't want to mess with the DLLs at that point. So let's go ahead and take a look at what happened here. Here we see restore has ran, clean hasn't ran, restore ran, then compile ran, and we get a bunch of warnings. The warnings really appear from here because I don't have a Git repository set up, whatnot. So those are the warnings. One important thing that I actually want to get across before we dive in too far is that NUKE itself is like a dynamic CLI tool which you extend with your build project, okay? So I'll repeat it. Your build project extends the NUKE CLI tool, all right? What do I mean by that? How does it extend it? So for example, here if we type in nuke help, it will tell us which targets we have, all right? So if we add another one, so for example, something like test, right? And again, we type in -help or targets. The targets probably didn't run, so that was a bad idea. Let me go ahead and cancel this. Right. Let's just type in help here. And here again, we're going to see the test, right? So it outputs new things. As it goes for the parameters, the configuration. So for example, we have this parameter defined here, and it is an object. So you could specify your own object here, but let's just get our heads around how we pass parameters into here. So if we take a look here, you can see that the parameters reflect in the CLI tool. So if we do something like read-only string hello, and we will say that this is a parameter, and we will say hello param description, right? And again, we'll run help. What you will see is you will see this parameter appear here, okay? So this is how your build application or build project extends the NUKE CLI tool, right? So as you're gonna trigger this from the build pipeline, like GitHub Actions or Azure or whatnot, we're gonna see how to integrate with that as well. You can pass dynamically parameters from that, right? So your CLI tool evolves based on what your application is, all right? So a little bit on this configuration. How do we have a type here, but we can only pass something like debug or release, for example? So you will need to use the type converter if you want to do something similar. So for example, in the type converter, what it will do is it will look for a static field, and then whatever string as a parameter that you pass into it, it's going to try to find that. So if we pass -- configuration debug, we're going to look for debug, and that is going to give us this configuration here, okay? And if we do -- configuration release, it's going to give us this one, right? So if we do something like, if we extend it with hello, and we will say something like Bob here, and we come back here, and instead of the regular configuration, we will just supply something like hello. So we actually do get the instance where the value is Bob. We're actually not going to see it. We will get an error because the Bob configuration doesn't actually exist. But in the restore step, we can actually use the logger. So you can do console write line, or you can use the logger, which is the preferred way. We will log a normal level of configuration, right? And just a note, configuration has implicit conversion to string, so it will just output the value here, okay, of this configuration. Okay, so again, let's just run it and just make sure that we are indeed getting that Bob configuration in there, okay? And I've put it in the test bit. Silly Billy. Let's try again. Okay, so that runs again, and there we go, right? So we're seeing Bob there being outputted here. Cool. Let's take this out, and let's take this out as well. And what I'm going, another thing that I want to show you is just the real power that it brings to the table. So once your build grows, you're gonna have 50, I don't know, probably not 50, maybe around 20, 25, but that's enough targets to actually be like, right, what is actually going on here? This is where nuke -- plan can be really, really useful. It creates a diagram where you can see what triggers what, right? So if we run restore, it doesn't trigger anything. Compile depends on restore, so restore will run and then compile will run. You will notice that clean never runs because it just has that before thing. Nothing really depends on it, so we don't really need to run it. We can start running it as well by doing something like clean here, okay? So again, regenerating the nuke plan. And by the way, you get a temporary folder here where this execution plan gets stored, as well as some logs around your build. Now, if we try to execute nuke, yeah, I just run the regeneration there as well, but here you can see that if we hover over compile, if we hover restore, only restore runs. If we hover over compile, clean runs as well. So if we run nuke now, from default from compile, what will happen is clean will run, but clean will run before restore. So if clean runs, it will run before restore. Okay, so you can see even the positioning here. Let's go ahead and close those two plans, and just kind of like you can run whatever you want really. So you can opt into just running clean. You can use all lower cases, so it's not like it depends on it's not case sensitive. Here now, if we just run nuke and we'll run restore and clean before it. Let's say we want to say run compile and we want to skip something like clean, right? So now clean will be skipped, restore, and then we run compile, right? So you have that flexibility again wherever from you choose to invoke this. Now that we kind of understand the ropes of a nuke, let's go ahead and figure out, well, didn't need to close that. Figure out how can we weave it together. How do we control the flow of our build? Okay, so as we kind of saw, as we saw, that depends on forces restore and clean to run before compile, and clean always runs before restore, and that's because of this before tag. So in short, you have a depends on, which basically states very clearly that this compile step depends on these two steps. Okay, so this is how you describe dependency, and that something is going to run before something else. So first clean will run, and if we don't say before, the order is kind of like gonna be as it's specified here, but in reverse. Like you're basically saying order doesn't matter here. Before, you will have, actually I should probably say depends on, and most of the things have an inverse in inverse motion, whatever I'm doing. Inverse, right? Whatever. You have depends on, and the inverse would be dependent for. So if we have this bit here and we don't want to specify depends on clean here, but rather say clean is a dependent for compile, this is exactly identical configuration as far as nuke is concerned. It's whatever you prefer more semantically. Okay, so this basically specifies triggers, what should run, right? There's also triggers, we'll cover that in a second. So depends on and dependent for. Again, this is all clearly described in the authoring builds fundamentals. You can look through that. Again, all the links in the description, and if you have spare money to go support the creator of this awesome library. Links are in the description. Next thing is ordering. So how do we say something runs before something else? Kind of like how we have here, before and after, right? So again, we have before and then the inverse is after. And this is really to order. This does not say that something is going to run before something else or trigger something. This is just to specify the order. So if they do run, if you are specifying the order in which they're going to run. Okay, the next bit, let's take a look at it, will be triggers. So same as with depends on and dependent for, you have triggers and triggered by, which is again triggers and then the inverse. So triggers something, triggered by. I mean, this Fluent API is really simple. Again, triggers and triggers by is actually going to trigger your target to execute, okay? And whatever thing you try to execute, I mean, there it goes, okay? And the actual difference between triggers and depends on, I'm not sure, although it seems like mostly semantical meaning that basically creates this differential between them. Next thing is, let's take a look only when dynamic, and we can also take a look at requires. So requires, let's take a look, let's see how this is different from only when dynamic. So requires, you can have some read-only string hello, probably shouldn't have deleted the parameter. Let's say description, right? And we'll say that, right, we do require our hello for this. Because let's say if you're trying to inject an API key or your NUGET package key, whatever secret, like where you're gonna deploy, etc., if that's missing, your build's gonna fail, right? You don't want to run like all the way through your build, and then when you try to pack and actually ship it, you're gonna fail because for some reason the secret wasn't supplied, right? You want to fail early. So this is what's going to happen. If I'm gonna run NUKE here, I'm not supplying the hello parameter, so what would happen in reality when we're running in the build agent, we won't be able to have an input. So this will just crash. Here it's actually prompting me for a description, which, I mean, I'm not gonna give it. So I'm gonna exit it, and yeah. So again, fail early sort of thing. We just wanna say, right, don't have an API key, no point running any of the build because it's gonna fail in the end. Let's just get out, and it's just gonna fail your build, okay? So that's what requires does. Now let's go ahead and take a look at only when dynamic. So we will change this to bool. Proceed, just to kind of maybe make it a little bit more understandable. We'll set it to false. So let's return it from here. Proceed. So here we're specifying only when dynamic. Only when this condition is true is that's when it's going to run it. So compile depends on restore. We can also say that we depend on clean because that's going to be useful in just a second. Let's go ahead and run this. So you can see clean runs, restore now doesn't run, and compile runs. We can actually go ahead and put this here, depends on clean, as it's going to be a little bit better for me for the next example. It doesn't change anything at this point. So first clean is going to run, and then restore is going to run. What we can do now, because this is dynamic, we can do something like, if this has succeeded, whatever result, some kind of operation performed, maybe we checked some kind of database and we set it to true. Now we want to run something else, okay? So here you can see clean, restore runs, and compile, right? So this is how you can dynamically control which steps you want to execute and which steps you don't want to execute, okay? The sort of the cousin brother of this function is only when static. So this doesn't really matter if you change this dynamically. This is same as the require. It's going to determine during the initialization of the build, right? So it's again trying to follow this fail early philosophy. All right, let's go ahead and say proceed here. So even though we change it to true, now what we do is when we run NUKE, it doesn't matter that we change it to true because only when static will look at the initial value, and that's it. So only when this is set to true from the beginning is when NUKE will basically say, right, actually run it, okay? When we're using only when static, this also allows us to use the when skipped option. So this will basically say, right, if this is being skipped, the restore function, you can see how if we're skipping the restore function, clean still runs. We may want to say, right, there's no point executing whatever this depends on because this is going to be skipped. So at this point, only compile will run, right? and there it is. So these two are skipped, and clean is skipped because we specify when skipped. Dependency behavior skip, all right? And this is the restore is skipped, and therefore clean is skipped because of this option. Now, another couple of things is what to do if your step is failing. So there is assured after failure and proceed after failure functions, okay? Or maybe options rather than functions or methods, whatever. Assured after failure, previous step fails, we still want to run this one, assured after fail. Proceed after failure, this one fails, restore fails, we want to keep going, yes, use that. So this is how you can handle if previous step fails or this one is failing, keep going kind of thing, okay? So those are another two options that are available for you, just kind of things that you can do with your pipeline. Another bit is unlisted. So let's say you're building a huge pipeline, you have 100 steps because you have mono repo, whatever, and some of it you just don't want to show it, you don't want to see it, right? Having unlisted will basically do something like this. So when you go nuke -- target to list your target, I think it just did it through help anyway, you can see it no longer displays in this list. So that's what it does, all right? In case you need to hide anything, it's kind of like having an internal variable or an internal class, whatever, and that's what that does. I think somewhere here, I don't have it anymore, but you see me use the logging. Again, logger, if you want to log anything, output anything to the console, you can use console write line, although logger is preferred. You also have access to this control flow class, which you have asserts, fail, just a way to sort of terminate a target. Okay, so if it's failing, if something's bad happened, you're just like, oh, come on, just fail it, right? I mean, if you know what you need it for, you know how to use it. If you need to fail your target to fail the whole build because of something that happened during execution, you do it for the control flow, okay? And then you assert or fail, right? So based on the condition or just fail it. And NUKE also comes with some predefined parameter, kind of how you can specify your own parameters here. I can't remember all of them off by heart, and I'm not going to go through source code because it's actually shown right here. Most of this is not important. Root directory is probably the most important one, you know, skip target, whatever. You can use these parameters, location of your temp folder, but the root directory will kind of very nicely bring us onto the next point where, let's say I want to, when I run a test, make a test run, I want to specifically point to the unit tests. So let's go ahead and create a new target. So target, we'll say unit tests. And by the way, if you're wondering what I'm writing right here, what is this thing, right? What are you looking at? This arrow underscore. Let's just first say depends on compile here and executes some kind of lambda. Right. So what is this notation for? If you ever watched any of my other videos where I build projections for Entity Framework, or if you've ever built projections for Entity Framework, or if you have ever used the expression API, where you could maybe have something like action string, so you're not returning anything, although in this case the target, whatever the type is, let's quickly comment this out, will be iTarget definition. So in the end, we'll be returning the target definition. So it's probably maybe a little bit more like a func string and a return string in the end, where let's say we'll say something like tt will be a function, we'll have a string, although we discarded, and then that will go into string. We'll say something like substring, and yeah, this is the same thing. And you know, we can chain these on here and clone whatever, right? So how we're chaining function here, this is just a Fluent API for chaining this, all right? So this is what this underscore stuff is. Really all you're interested in is this part here. Okay, anyway, for the execution of unit tests, how we have .NET build here, let's take a look at one of the other functions that we have here. .NET run, we don't necessarily want that, we want .NET test. So here let's go ahead and provide some settings. We're gonna say .set project file, And here we can grab the root directory. And one important thing to note here is the root directory is an absolute path. Absolute path is a special kind of class that makes it really succinct to work with strings and like combine them and stuff like that. So what I'm talking about is when we want to specify the directory of our project, we take the root path, which is going to be our solution. We say slash, so no pluses, nothing like that, no concatenation, right? Nada. We say dash.api unit tests. Bushka, right? Awesome. Enable no build because we already built, and enable no restore because we already restored as well. Okay. Now, the only thing that we'll do here is we'll run this unit test. Let's go ahead and specify that as our entry point. Let's go ahead and nuke this. Clean, restore, compile, and unit tests. Again, just run one past, which obviously it's not a real unit test, but whatever. Now, before, just a quick intermission of like maybe a little bit more useless feature. I don't see myself using this one too much because it's based on events. I mean, you already have depends on triggers. Those are kind of events. But here you have on build created, on build initialized, on build finished, on target start, whatever. You have all of these events. So you have options with some events. Go ahead and explore those. I had no use for those just yet. The last two things that we're going to cover, these are quite cool, right? And this is the part which really lets you use Nuke for anything because it allows you to import any tool that you want. And if you're like, what's a tool, right? The .NET, any CLI tool, that's a tool. Git, Node.js, NPM, Ionic, Closure CLI. Yeah, Closure has a CLI. Yeah, but no, whatever. Any tool, any executable. Let's go ahead and take a look at how this looks. So you say path executable. This means that it's contained in your environment variables, or if you're on Linux, it's in your path, which if you're on Linux, you know what you're talking about. All right. Read only, you say tool, and then git. Right. So the name corresponds to what you have in your path executable. So when we run clean here, I think let's go ahead and take this out. Here I will just say logger, normal, and actually I don't need that. Git runs like a function. So in here, git will be the first parameter, and then we want to say status, right? Get status, what's up with my repository. So let's say get status. This is the kind of output that we're expecting. So let's go ahead and say nuke clean. So I only want to execute that part because I just want to see what it's going to output. And you can see it does this exact output. So you can have a C# building any of your JavaScript projects. You can use this for Node, compile your JavaScript, run your JavaScript tests. I mean, again, world's your oyster. And if you think about it as being an abstract layer on top of all the CI providers, which doesn't have full support, but it's getting there. So just a quick CLI tools, just all the things that it provides. But what we just touched on, the path executable, where it uses the tool git. You can have a local executable. So if it's not a path executable and you've just like had to pull something or download something just for this build, go ahead and specify it. Path executable. If you're downloading a NUKE package to run this build, you have to reference it, use it, man. All right, so that's it. So CI integration currently supported for TeamCity, Azure Pipelines, AppWare, GitHub Actions. Let's go ahead and see how this integration actually looks like. So Git right here, let's go ahead and remove it. We don't really need it anymore. And going to the top here, this is how you specify the generation of the YAML file that is going to trigger your NUKE build. Okay, you specify provider, GitHub Actions, and then you fill out the constructor. In our case, it will be build and test. This is what the name of the YAML file will be. We'll then say what machine we want. You can specify multiple machines here, so Ubuntu latest, Mac, whatever. Now, to make it generate, all you have to do is you have to run nuke, right? So if you don't want to execute nuke specifically, just run nuke --help. And again, it's just gonna put that it generated something, and you can see the linked file is here, but in GitHub build and test YAML, this is what you have here. So you see we don't have any on events. And again, as these build tools get built up, you can specify multiple things. So like on push branches, there it is, push branches, new array, and we'll say master, right? So only when we push on master, that's when we want to trigger this. I primarily only use workflow dispatch for my small projects, and that option is not here yet, so it should be implemented soon though. Here you can see us influencing this build pipeline and how it gets generated. And you can see all it's doing here is it's just going into this build CMD, which in its turn will execute build.ps1, right? Which in turn will make sure that all correct tools are set up and that your build can run. And that's pretty much it for the overview of tools. I still haven't covered everything. There is, I'd say, a lot more to it than just what I've talked about here, because again, you really need to experience this as well. Don't forget to get a plugin for your IDE. And let's go ahead and actually take a look at how would we integrate our application into this build, right? So the test API, we want to build it. We want to run our unit test, just kind of how we did. We want to run our functional tests in the build pipeline as well, okay? So let's take a look at how that might work. We will delete this Git folder. Here we have a clean, restore, that's fine. So clean, run before restore, depends on clean, that's fine. We can just remove this before because restore depends on clean. We have compile, which depends on restore, so that will trigger restore. And then we'll have unit test, which depend on compile, right? So let's create run tests. Okay, that's really what we want to do. So target run tests. This will depends on unit tests and functional tests, which we haven't created yet. So let's go ahead, maybe grab around this much, duplicate this, put this down here, and let's grab these functional tests, put them here. All we want to do now is we want to run our functional tests. So instead of unit, let's specify functional, and let's go ahead and run this. Now, not help, just NUKE. If you remember how we tried to run our functional tests, I don't think we ran them without our actual application running. But basically, because our application isn't running and we are trying to execute our tests, everything is just going to time out. So it's going to fail, and then you can see the other steps haven't ran. How do we start up our application before the functional test and then kill it after? Okay? Because maybe for some other test, you're going to need a fresh instance, right? So you need a very repeatable way of building it up and scrapping it. So, functional tests. Before our functional tests run, what we want to do is we want to start our API. This will, let's say, it will involve something like saying executes, and in our executes, we need to start our API. Now, we could potentially use .NET Run, although that just gives us back the output, which we can't really use because we want to kill our application later on. So for this, we can use process tasks. Let's say start process, and here what we're going to have is, maybe if it will give me a little tooltip on the top here so you can see, saying toolpath. All right, what's the tool that we're using? .NET. Okay, what are we trying to do? Arguments. We're trying to run it. Okay, working directory. What's the working directory? Well, we know the working directory is just the test API. And there we go. So here, what we do now is functional test depends on compile, right? So it really does depends on compile, and it really depends on having the API being started. So now before functional test is going to run, it's going to start the API as well. What we want to do is, let's copy this, put this here, and we'll say stop API. This is where we want to take this process and we want to kill it here. Okay. So let's go ahead and remove this. We're going to come here and we're going to say API process, right? equals this thing. We'll create a property. We'll create it here outside. Public. This doesn't really need to be public. I mean, this could probably be a field as well. And there we go. So that looks a little bit weird. Got one too many semicolons. So when we start our API, we save the process. Then we go ahead and stop our API. So we go ahead API process and we kill. Okay. And then once functional test runs, what we want to say is triggers stop API. All right, because that's very semantically sound, I think. So as the first thing, just kind of overview, first thing that we do, we run our tests. So run tests involves depending on unit tests. So that's this thing here, and functional test, this thing here. For functional test, we depend on compile as well as for our unit test. So compile will run before both of these. We will also, for our functional test, depend on start API. So start API will start before the functional test run. It doesn't matter if it will start before compile and whatnot. Then we also have the stop API, which will run after a functional test. And then this part is pretty self-explanatory. I think I'm not going to go over it because we ran it like 10 times as well. So we can take a look at NUKE plan. This command can be very important in terms of figuring out where do you have a problem in your build, what runs before what, like what's the flow of your build. All right. And really here you can see which things are going to run depending on what we trigger, right? So even if we trigger just stop API, none of the rest of these applications will actually be triggered, right? Let's go ahead and call NUKE. Let's see, build failed. What is this? I just run plan there. Okay, I thought that was a legitimate run. I was like, why is it failing? Yeah, anyway, functional test run here. So you can see our application starts test pass 2 and then unit test pass 5 seconds to run functional test. I mean, there's not much to it, but nevertheless, here is a pipeline for this current scenario where you have unit test, functional tests on an API that we spin up. One more thing that I'm going to say is that you will have is .NET publish and pack. So you can pack up your NuGet application, you can publish it, you can again NuGet push, you can accept API keys as parameters, multitudes of stuff. And another thing, if you're taking an interest and you're going to take a look at this, a very good place to look for examples is the build pipeline of the NUKE build project itself. So you go into build, you go into build CS, you take a look at the rest of it as well. But here it also shows you how to get your secrets imported into GitHub Actions, other providers as well if you're using TeamCity or Azure Pipelines or Appware, and really just full of really great examples in this repository as well. This will be it for this episode. If you enjoyed it, leave a like, subscribe. Don't forget to go and support Koch. I hopefully pronounced his name correctly, the guy who created this amazing build system. If you have any questions, make sure to leave them in the comment section. Come join the Discord server if you haven't already joined the community. And hopefully, I'll see you in my other videos.